Hi everyone. In this video, we would be learning about Singleton Design Pattern, which is a part of Creational Design Pattern. So in order to understand Singleton Design Pattern, we'll try to answer these three questions. First is, what is a Singleton Design Pattern? Second is, what will happen if we don't use Singleton Design Pattern where it is actually needed? And third is, I'll show you how to convert a normal class into a Singleton class. We'll further see whether this singleton class will work in multi-threaded environment or not. And if it does not work, then we'll make it work. Okay. So now let's check out what and why part with the help of one example. So this is the setup where we are first using this class. This can be your service code. Then we would have one cache object like this. And there is one database which stores the user data. Okay. So this class is first creating the object of cache, that is this part. Then it is trying to fetch the user by ID 1. So first this class will check the cache, whether that cache has the user with ID 1 or not. And if it does not have, then this class will directly request the database like this. Okay. Now this database will send the user data to the class. So this particular data will be sent. Okay. And it will also store the user data into the cache so that for the future request, we don't have to make a call to the database. So now the cache also have the user data of user ID 1. Okay. Now let's say this class again wants to fetch the user by ID equals to 1. So now it will not make a call to the database. Instead, it will first check to the cache, okay? And the cache itself will return the user data like this, right? So currently everything is working perfectly. But now let's introduce one more class. Let's say the name is class 2 and right now again this class 2 is creating the new object of this cache as you can see over here, right? So it would be empty. There would be no user data present into this cache. Now this class 2 is again fetching first time it is fetching the user by user ID 1. So it will first check the cache whether that user ID is present or not. And it is not present. Hence, it will make a call to the database. So let's say this is the call to the database. And this database will send the user data to the class. Okay. And it will also save this into the cache as well, so that for future requests, you don't have to make a call to the database. Okay. And then let's say again this query comes. Now this time also, it will first check the cache, and cache has the user data corresponding to user ID 1. So it will return this particular user. Right. Now what problem can you see in this particular setup? So let's list down some of the problems over here. The first problem that I can observe is, since see, class 1 is also creating the cache and class 2 is also creating the cache. So this particular user is also present in this cache and it is also present in this cache. Now let's imagine there are hundreds of these classes. It means that this particular user will be replicated hundreds of times, right? So we are wasting a lot of memory. Okay. Now, second problem that I can see is, since this class 2 is also creating the new object of this cache, hence it would be empty initially, right? So it has to make a call to the database. Now this call has certain overhead. So the first one is the network overhead, because obviously this database is present into some other server, right? So from one server you have to request to the other server. So network overhead will be there. And in the database, the actual data would be stored into the disk, right? And this cache is present into the RAM, because reading through RAM is faster compared to reading to disk. So here we are performing disk read. Why we are performing disk read? Because initially this would be empty, and since it is empty, we have to make a call to the database and then read the disk, and then this database will return the user object, right? And that's the reason why we have this second and third point. What if I say that instead of creating new object like this, it just use one single object like this? So now let's again dry run that particular flow. So let's say class 1 wants to fetch a user with user ID 1. So it will first check the cache whether that user is present or not. Currently it is not present. So what it will do is it will ask this particular database, and this database will send the user object, and this class will save the user object into the cache as well for the further request. Now let's say class 2 wants the same user. So it will first check the cache, and indeed that user is present into this cache, as you can see over here, because it was saved by the class 1. So now the cache will return the user object. This was possible because we are using one single object of this cache. So the problems that we were facing, the first is memory wastage. Now we are not wasting memory because we only have one cache throughout our application. Okay. Second is network overhead. Now this class 2 is not making a call to the database. Also, obviously, since it is not making a call to database, there is no disk read operation, right? So we have successfully eliminated all these problems by using one single object throughout our application like this, right? And this is what singleton object or singleton instance is. See, any object which is shared across your application is called singleton object or singleton instance, right? So I hope you understood what is singleton and why we need singleton design pattern. So singleton design pattern is needed so that I can create such single object which is shared across the application. Okay. So some other examples are, like first example we already saw, the in-memory cache, like we were using the cache to save the user data. And second is DB connection. So this connection that you are establishing from your client to the, I mean, from your server to the database should only be one. Like you should only establish one single connection throughout your application. Why? Because let's say you have thousands of such connections to the database. Then obviously the load on the database will increase a lot, right? Secondly, you need to establish the connection, then you will perform some CRUD operation, and then you need to close the connection. Now, if there are 100 connection, then you need to repeat this step 100 of time, right? So if you have just one connection, then you don't need to repeat it again and again, isn't it? And that's the reason why we should have one single connection across the application. And third is for configuration manager. Like you will share same configuration across your application, isn't it? So these are some of the example. So the point is, whenever you want to share one single object throughout your application, then you will opt for singleton design pattern. So I hope now you understand what and why. Now we'll see how to convert a simple class into a singleton class. Okay, so let's check out that. So we'll be working with this particular example of database connection. So whenever any class will create the object of this DB connection, at that point, a connection will be established to the database. Okay. So for example, in the main class, if I create the object of DB connection, then one connection would be established. So let's run this code. So as you can see, a connection is established to the database by connection 1. Now if I again create the object of this, and let's say the name is connection 2, and if I run the code, then there are two connections which are established. And we have clearly discussed why we need only one connection throughout the application, right? So it means that I have to now convert this simple class into a singleton class. So for that, first thing is, here we can observe that the main class has the rights to create the object of DB connection, right? So since it is able to create the object of DB connection, this particular connection is established. So somehow I have to restrict the object creation process. Like I don't want to allow any class to create the object of DB connection. So for that, what we can do is I'll convert this constructor to private. Hence, no one can create the DB connection object. So I have to remove these two lines. Done. So the error is gone. So the point is we have restricted the object creation process. Now no class can create the object of this particular class. Now how this main function or how this main class can get the object of this DB connection, right? That's the main thing to focus now. So for that, what we can do is, since this is private, since this constructor is private, it means that this class can create its own object. No one outside can create the object. So we'll create one function like DB connection, get DB connection, and this function is responsible to create the object and return it like this. And since this object needs the name, so we'll pass that as well. Okay. So what this function will do is it will create the object and return that object. So when main function wants the object of DB connection, it will request or it will call this function. Now, by the way, we can how the main class can access this function without creating the object. So for that, what we have to do is we have to make this function as static. So now the main class can say DB connection dot get DB connection, and let's say the connection name is connection1. So if I run the code, we can clearly see that connection is established to the database by connection1. Now if I duplicate this line, that is if I call this DB connection one more time, and if I run the code, just a minute. Yeah, if I run the code, then there are two connections which are established. So it means that this particular class is still not converted to a singleton class. Now let's analyze why. So whenever any class calls this particular function, what we are doing? We are basically creating the object and returning that object. And if this function is called 5 times, it means that we will create the object 5 times. And this is what we don't want. We only want that object should be created only once. Right. So for that, what we'll do is we'll have certain checks. So let's say there is one variable DB connection, which would be initially null. So we don't need to specify null because objects are null by default in Java. So we'll first check whether this connection is null or not. And if it is null, then only we'll assign or we'll create this object and assign that to the connection variable. And finally, we'll return the connection variable. Now this is showing error because the current function is static, so this variable should also be static. And I don't want any class, like this class can access that variable, right? db connection dot connection. And I don't want this to happen, because they can access and they can create, or they can do something else as well. They can point this connection to something else as well. So what we can do is we'll make this private. Okay. So now whenever someone calls this function for the first time, this if condition would be true, and then this object would be created and it would be assigned to connection, and finally we'll return that connection object. And when we'll call this function second time, then if condition would be false, because connection is already assigned. So we'll skip this block and directly return the connection. So let's check whether it is working or not. So now I'm running this code. So now we can clearly see that there is only one connection, even though I have called this function 2 times. So we have successfully converted this class into a singleton class. But will it work with the multi-threaded environment? Let's check out that. So for that, what I'll do is I'll create a couple of threads. Let's say T1, and it will execute this particular line of code. And let's say there is one more thread, which is T2, which will execute this line of code. And I'll finally start both of them. Okay, so now let's run this code first. Now we can see that multiple connections are established. So let's try to analyze why this is happening. So this thread T1 and thread T2 are simultaneously calling this get db connection function. So they are over here, let's say. They're simultaneously calling this function. So they both will simultaneously go inside this function, and they will check whether the connection is null or not. So for both of them, the connection is null. Okay. So they both will go inside the if block. And since they both are inside the if block, they both will create the object. And this is the reason why the connection is established 2 times. Okay. So I have to prevent both of the threads to go inside this function simultaneously. In other words, I want only one thread to go inside this function. So for that, what we can do is we can introduce synchronized keyword. So this synchronized keyword will only allow one thread at a time. The ordering does not matter. Like thread T2 can also go first, or thread T1 can also go first. So what basically will happen is, let's say T1 decides to go inside this particular function. So only one of them will be allowed. So T1 goes inside that. It will see that connection is null. So it will go inside this if block, and it will create the object and assign that to the connection variable. So finally it will return the object. Okay. So this was of T1. Now T2 will go inside the get db connection function. Now it will see whether this is null or not, and it would be not null because T1 has already assigned one object to this connection variable. Hence, it will skip this particular if statement and directly return the connection object. So let's see whether this works or not. So indeed, it is working. So even though I am having 2 different threads, then also only one connection is established. Okay. And as I was highlighting that ordering does not matter. So currently thread T1 is establishing the connection, right? So let me run this few times. Yeah. So here you can see that after running few times, connection 2 is establishing, thread 2 is establishing the connection. Okay. It means that thread 2 was allowed to go inside this function first, and then thread T1 was allowed. Okay. So I hope you got this particular usage of synchronized keyword. So now our code also works in multi-threaded environment as well. But the point to note over here is this synchronize keyword is bit costly and we don't need the synchronize keyword after object creation process. So let me show this via one example. So let's say again we have T1 and T2 threads, and let's say T1 is allowed to enter the function. So T1 goes into this function, it will check whether this is null or not. So it will be initially null. So it will assign it will first create the object and it will assign that to the connection variable and finally return the object. So this was for T1, and then finally T2 will be allowed to enter this particular function and it will skip this particular if statement and directly return the object. So this was the case when initially for the very first time T1 and T2 are simultaneously calling this function. Now let's say after few minutes, let's say after 5 minutes, there are multiple threads T1, T4, T5 up to let's say Tn. Okay. So all of them are calling this function simultaneously and the object is already created. So since all of them are calling this function simultaneously, even if they go inside this function simultaneously, they will not cause any issue because they all will skip this particular if statement because connection is already assigned to one particular object. Okay. So they will skip this particular statement and directly return the connection object. So there is no use of this synchronize keyword, isn't it? But since this synchronize keyword is mentioned over here, and that's the reason why only one thread of this will be allowed to enter the get db connection function. So first T3 will enter, then T4, then T5, then Tn, and so on and so forth. I mean, ordering can alter, but point is only one thread will be allowed to enter. And obviously, this will slow down our application, isn't it? So I have to somehow come with another approach which is optimal. Like in that approach, this synchronized keyword should only be used only for first time, only during the object creation process. So for that, what we'll do is instead of having synchronized function, we'll have synchronized block. So let's remove this and we'll have synchronized block. Okay. So this is a synchronized block. Now all of these threads are allowed to go inside this particular function because this function is no more synchronized. But still they have this synchronized block. So they will be allowed one at a time only. So first T1 will go, then another thread will go, then another, and so on and so forth. So still we haven't optimized the particular synchronized function or synchronized block. So for that, what we can do is we'll have one more null check over here like this. So now, even if all these threads are allowed to go inside this function simultaneously, they will see that the connection is not null. So they will directly skip this particular if statement. And since they are skipping this particular if statement, they are also skipping this particular synchronized block. Hence, we have optimized our code, isn't it? So when for the first time we had, let's say, thread T1 and T2, at that time, this particular block will be executed. After that, we will not be executing that block. We already saw this thing, right? So we have optimized our synchronize function, and this particular approach is called double check locking because we are using this null check 2 times. Okay. And here you can clearly see that IntelliJ is also highlighting this stuff. Okay. And it is also highlighting one more stuff. See, it is highlighting that make connection volatile. So let's make it volatile. So this connection has now become volatile. Now, what's the use of making this volatile? Let's understand that thing as well. Now let's try to understand why exactly we are using this volatile keyword in front of this connection variable. So for that, I've taken the same example. So this is the synchronized block and we have thread T1 and thread T2. And let's assume that connection is null. So initially, let's say thread T1 goes inside this synchronized block. So it will see that connection is null, hence it will go into the if block. So currently we can see that there is only one line. Okay. For humans, it can be one line, but for JVM breaks this particular line into 3 steps. So these are the 3 steps. First, it will allocate the memory. Second, it will construct the object. Third, it will make the connection variable point it. So we know that in Java, there is something called as heap memory where all the objects are stored. So first, JVM will allocate the memory for the object that is going to be created. That is this object. So let's say this is the memory location which is allocated. Okay. Now second is it will construct the object. So in this memory location, it will construct the object. So let's say now object is constructed. Okay. Constructed means all the variables would be assigned and all those things. So after it is constructed, what will happen is it will make the connection variable point to that memory location. That is this part. It will make this connection variable point this memory location. So these are the 3 steps that JVM will perform for this single line of code. Okay. But sometimes what JVM will do is instead of performing these steps in this order, it will try to reorder this for optimization. So JVM will see that constructing the object is heavier task compared to making the connection variable point to the memory location. So JVM will first allocate the memory. That is, it will first allocate the memory. Then it will make the connection variable point it. Okay, like this. And afterwards, it will start constructing the object. Okay. So let's say it starts constructing the object like this. So currently the object is not fully constructed. It is in the state of getting constructed. Okay. And T1 exits the synchronized block because all the 3 steps are started, or I mean step 1 and step 3 is finished and this is started. So thread T1 goes out of this synchronized block. Now thread T2 goes inside this synchronized block and it will see that connection is not null because connection is pointing to some memory location, isn't it? Like this. So it will get this particular object which is halfly constructed, and this can be dangerous, right? Because this particular object is not constructed properly. Hence, whenever you'll use this object, there are high chances that your code can break, right? And in order to prevent this entire scenario where the steps were getting reordered because of JVM, we are using this volatile keyword. So whenever you'll use this volatile keyword, the steps will not be reordered by the JVM. Okay. So now I hope you understood why are we using the volatile keyword. So with this, we have seen how to convert a normal class to a singleton class and how to make the singleton class work with the multi-threaded environment. So I hope you understood this singleton design pattern properly. If you did, then please like the video and subscribe to the channel. Thanks a lot.